Hello, good evening all of you. Welcome to this revision session. So already we started long back, but due to some technical problem, I could not start the session, my second session. So as we started already this session long back, so it's a revision class. Already you people took this course with some top educators from this platform or any other platform also. But this is a revision course useful to everybody. The final phase of your preparation, this is a very important phase, very deciding time. This is decisive time. You should not waste your time, especially at the fag end of your preparation. Okay, so the valuable time. So I don't want to waste your time also, so straight away jump into the revision class. So revision is very important for any subject it is very important, and here we are emphasizing more on important subjects so that this will help you in getting the best score in the exam. You can maximize your score with the help of this particular session, course, okay, revision course. So especially the GATE exam, just 2 months time, 1.5 month time left with us. GATE, those who are preparing for GATE exam, especially civil engineering aspirants. So one of the important subjects for civil engineering students is environmental engineering, right? One of the important subject is environmental engineering, where you can score maximum number of marks. In GATE exam, its weightage is almost minimum 10 marks, and it may go up to 15 marks also. So 10 to 15 marks, it may vary anywhere between 10 marks to 15 marks. So it is easy course along with other courses, such as geotechnical engineering. There 14 to 16 marks will get in the exam. And with transportation, also very important course, where you can score maximum 9 to 11 marks in exam. So these three courses are major courses, very deciding in deciding your rank in the exam. I mean, in deciding your success in the exam. How successful you are, that depends on how many marks you score in these three subjects. They are easy only most of the times in GATE exam. GATE exam is more of numerical oriented. They ask tough numericals. Okay, tough numericals they will ask compared to other competitive exams. So when you prepare thoroughly for GATE exam, it may help you through numericals. You can learn the concept also. So you can write any kind of exam with the help of with this preparation. What I mean to say is, so today I am starting the course on environmental engineering, revision course on environmental engineering for civil engineering aspirants. Okay. If you see the environmental engineering course, if you see the content of the course, content or syllabus, whatever it may be. So this course is divided, the subject is divided into 4 parts. One is water supply engineering. Second is wastewater engineering. And third one is third component of this subject, solid waste management. And fourth part of the subject is air pollution and control. Earlier noise pollution also included in this. And nowadays, recently they have removed that, air pollution and control. So most of the questions will get from water supply and wastewater engineering. This is called, from water supply almost will get 5 to 6 marks. From there only will get 5 to 6 marks. It is almost as good as any other subject, full subject it is. See, now some subjects, so though syllabus is very vast, syllabus is there in them, but still weightage is only 3-4 marks. When compared to that portion of its environmental engineering, that itself is a separate subject. Water supply is one subject, wastewater is one subject, solid waste, air pollution and control also different subjects. All put together it is called environmental engineering. Okay. So from here we get 4 to 6 marks, minimum 4, maximum 6. From solid waste management and air pollution put together, so you may get anywhere between 1 to 3 marks. So it may vary anywhere between minimum 10 marks and it may go up to 15 marks. So year by year they are giving more weightage to this course. Therefore you need to pay special emphasis while preparing for this exam. Especially you need to focus more on these 3 subjects: environmental engineering, geotechnical engineering and transport engineering. And these 3 subjects will give you that first hurdle, that is qualifying in the exam. After that, beyond that, anything extra you score, that will improvise your performance in the exam. That will improve your rank in the exam. That improve your, you get your success rate increases. You start performing better and better. Okay, anyway, without wasting time, let us straight away jump into the subject. So, I don't like to preach much. Let us straight away start water supply engineering. First thing is, you need to know where exactly numericals, scope is there for numericals. There you need to focus more. Just if you learn numericals also blindly, it is of no use in GATE exam, because numericals you can solve only if you have a good concept with you. With a good concept, you can better understand the subject, you can understand the subject properly. Then with that crystal clear understanding, then you can properly work out the numericals. So it is only one time preparation. One time you thoroughly understand the subject, then any exam, it is a cakewalk to you. It is not a big problem for you in answering the questions in competitive exams. So coming to water supply engineering, again, so here again I will write some topics which we cover here, where numericals, chance is there for numericals. The first topic is population forecasting. And water demands. And second topic is sources of water. So here we discuss about surface water, groundwater, etc. Surface water and subsurface water. We talk about that. And third topic is collection and conveyance of water. And fourth topic is water quality. Fifth topic is water treatment. In water treatment, again, you come across with so many topics. They play an important role. Sedimentation, coagulation, filtration, disinfection. Okay? Hope you are following. And miscellaneous treatment methods. Then, in addition to that, the last topic is the water distribution. So there are six topics in this water supply engineering. So here you need to focus more on two topics. One is water quality. From here you will get one or two questions from this topic. From water quality itself, very important. Doesn't mean that remaining topics you can ignore. You should have idea, but water quality should focus more. Then water treatment. Between sedimentation and coagulation, you will get 1 2 marks question. Between filtration and disinfection usually, you will get 1 2 marks question. That means you will get to 2 questions from here, water treatment, right, accounting to 4 marks. Okay. Between sedimentation, coagulation, always there is 1 question. Between filtration, disinfection, there is always 1 question. And anything extra you learn, that's a bonus for you. So these 2 topics are very important for GATE examination point of view. In addition to the other numericals, wherever there is a scope is there for numericals, just you supposed to have idea, but you need to focus more on water quality and water treatment, these 2 areas. From there only maximum they can give questions. Okay, so let us start without wasting much time. The first topic, population forecasting. And what is this population forecasting? Why we should forecast population? We all know that our day start with water, our day end with water. Without water, you can't imagine your life. Okay? So, we demand different amounts of water at different time periods of a day. Okay? Morning some amount of water is required. Afternoon some amount of water is required. Night some amount of water is required. Throughout the day we keep on using water for different purposes. Could be for drinking purpose, could be for bathing purpose, or cleaning your vehicle, washing your home, cleaning your utensils, washing cloth. Many purposes, even flushing toilets. We need water. So without water, we can't imagine our life, isn't it? Water plays an important role in our life. Who will supply this water to us? Local body. In whichever community we are living, the local body of that community usually supply water to the public living in that community. Okay? Why they supply water to you? It is a duty because we pay taxes to the local body. Local body could be a municipal corporation. It could be a municipal corporation. Right? We pay taxes to them. It is their duty to see that we happily live in that community by serving us properly. They are in business, truly speaking. Okay? So, their duty is to supply water. Why we depend on them? We can also have our own water on our own because that is costlier. If we try to get water on our own, the overheads will be more. It becomes very expensive. Municipal corporation always supply water at a thrown away price. You can't imagine the price at which we get water for different purposes. Right? So therefore, we always look at municipal corporation water, municipal water, isn't it? So how they supply water to the public living in a community? Communities are very big. City like Mumbai, almost 2.5 crore population live there. Very big city. So throughout that city, that the Mumbai Municipal Corporation, the Greater Mumbai Corporation supply water to them, isn't it? 2.5 crore population get water from Mumbai Municipal Corporation. So how they supply this water to them? By using a water supply system. Municipal Corporation supply water to the public living in a community by employing water supply system. So, to design the system, municipal corporation has to employ, to plan the system, to design the system, to construct the system, to operate the system, to maintain the system, overall managing the system, municipal corporation has to employ civil engineers. Civil engineers working with municipal corporation, their duty day in and day out is to see that public get enough water to meet their demands. Because we are municipal corporations serving the public, not free of cost, on payment basis. So when they are paying to you, it is your duty to see that your customers are happy. Customers are treated as gods. Who are the customers here? Population living in a community, public living in a community. Community could be a village, community could be a town, community could be a city, community could be a colony, whatever it may be. It is a community. Community is nothing but a group of people living at a place. Okay? So that group of people living at a place known as a community, they get water from the municipal corporation using a system. Municipal corporation uses a system to supply that water to the public known as water supply system. What is this water supply system? We all know that water is not a factory made product. It is a natural resource. The plenty of water is available around us. So nature gives water to us. So civil engineers, they have to collect water from nature. That water which they collect from nature, it is not in good in terms of quality. They have to improve the quality of water. Once quality of water is improved, then water become perfect, water become fit to use. Once it becomes fit to use, then that water is supplied to public. So here there are two aspects are there. One is quality, the other one is quantity. Both of them are very, very important. Okay? Right quality of water, right quantities, they need to supply to the public. So the object is water supply system. This water supply system we have to design, we have to plan, we have to design, we have to construct, we have to operate, we have to maintain, we have to manage. So to perform all the jobs, planning job, design job, construction job, operating job, right, maintenance job, and as well as management. So it requires a knowledge regarding the system. That's what we try to learn in water supply engineering. Water supply engineering, what we learn? Knowledge regarding water supply system. We gain some knowledge regarding water supply system. So with that knowledge, we better deal with that system. Okay, we perform all these jobs. Somebody may be in planning section, somebody may be in design section, some civil engineers work in design section, some civil engineers work in construction, execution section, some civil engineers work in maintenance section, some civil engineers in operating section, something like that. So they are employed at different places within the system. So they are supposed to have a knowledge regarding the system. That's what we try to learn. So this water supply system start at a source. Water is available in the form of a source. Source could be anything. Source could be a river. Source could be a lake or a pond. Source could be a reservoir. Whatever it may be. Either it is natural or artificial, whatever it may be. Water is available at source. So our job is what? We have to collect this water from the source. Collection. Then this water is taken to the place where we live. That's called conveyance. Conveyance is nothing but transport. Then this water is not in good terms. Therefore we have to improve the quality of this water. Therefore we have to treat, we have to purify that water. Once we purify that water, this water we can distribute. I don't have space here. I will adjust. Okay. I like little small letters. Is it okay to you know? Am I conveying information to you? So it is collection. First job is collection. Second job is conveyance. Third job is treatment. Fourth job is distribution. Distribute this water to the public. If you see the content now, the content composes this only. How to collect this water. To whom we supply this water? To the public living in a community. What is community? Community is nothing but a group of people living at a place. So community could be a town, a city. It could be a town. It could be a village, or it could be a colony. It is a city or a town or a village, etc. So in between, what is there? Between source and community, a system is there. That system is called what? Water supply system. We call it as water supply system. Understood? This system is called water supply system. Who will plan this system? Civil engineers working with municipal corporation. Who will design the system? Civil engineers working with municipal corporation. Who will execute? Who will operate? Who will maintain? Who will manage the system? All of the jobs performed by civil engineers. We plan the system, we design the system, we construct the system, we operate the system, we maintain the system, we manage the system. To perform all these jobs, we know supposed to have a knowledge regarding the system. That's what we try to learn in this course. So here two things are there. The system we have to plan and design. Initially we have to plan and design, rest of the jobs follows automatically. So to plan and design the system, what you require? You want to design a beam. Design of a beam means what? Fixing the size of the beam. What is the length of the beam? What is the width of the beam? What is the depth of the beam? How much reinforcement is required? This and all called design of the beam. How we fix the size? How we fix the size of the beam? Based on the loading. If you apply more load, large size beam is required. If you apply less load, small size beam also can work. Exactly same way. Water supply system also designed in the same way. So what is the size of the system? How big system we need to provide? That depends on what? Load. What is that load here? What is that load? Structural members are designed for gravity loads. There is a hydraulic system. Hydraulic system is designed for what? Hydraulic load. So water supply system is a hydraulic system which deal with water. Any system which deal with water is nothing but a hydraulic system. All hydraulic systems are designed for what? Hydraulic load. What is that hydraulic loading? What is that hydraulic loading in our language? We call it as Q. Flow rate or discharge. Discharge is nothing but what? How much amount of water we need to treat in a given time. How much water system has to deal in a given time. In 1 hour, how much water we are supposed to deal using the system. How much water system has to manage. So that's called hydraulic loading Q. So if you see this Q is nothing but, in our language civil engineers call it as discharge. So this Q, discharge or flow rate. Rate of flow. This is called hydraulic loading, which is a function of what? Depends on what? Which is a function of population of a community. How much water we need to supply. That depends on how much people living there. Population of a community. It also a function of water demands of a community. Their per capita water demand. How much water they demand. Not only that, we also keep one more technical term in our mind, that is called design period. So discharge is a function of population, it is a function of water demand, it is a function of design period. Okay, so if you see the Q, this Q, how we work out? So population at the end of design period into population, if you multiply with the per capita water demand, then you will get what? Q value. See now, when you have to work out population at the end of design period, what is that design period? Future period. We always design system for future, not for present. Why you are preparing for GATE exam? To have a bright future, to have a good future. Keeping your future in your mind, you are putting extra effort in taking up competitive exams, isn't it? With BTech also you will get a job. You can go to any construction job. Anybody, the graduation is more than sufficient to get a job. Then why extra effort is required for GATE exam, ESE exam, this and all? Why you are taking? To have a bright future, very good job. You want to settle down in you want to get a very good job so that your future will be bright. To have a better future, extra effort you need to put, isn't it? It's exactly same way. We always keep future in our mind. So design period is nothing but a future period. So we don't design for today's population, we design for future population, because system has got certain life. Life period of a system is different, design period of a system is different. This design period is nothing but utility period or useful life period. So I can live for 100 years, but I'll be useful for my family, for my people, for my state, for my nation only for 60 years. After 60 years, I am of no use because nobody will give job to me, isn't it? 60 years is the retirement period. After retirement, I have to relax. I am now more useful to anybody. So till 60 years, I have to work. I am useful to country. I am useful to my family. I am useful to many people. Many things are around me, isn't it? Exactly same way. So every system has got a design period. Till the end of the design period, we expect the best out of it. So therefore, design period is nothing but a future period. Suppose this design period always less than life period of a component. Design period is always less than life period. Life period is different, design period is different. It may have a 100 years life, but it is functionally it is useful only for 50 years or 60 years. That functional period is known as design period. So design period is nothing but future period. Okay? So we always design for future population. So how we can find out future population? What happens tomorrow? No idea. We can't predict what happens tomorrow. Today only important for us. Tomorrow what happens? No idea. We may have class, we may not have class. I may be there, I may not be there. Right? No guarantee for future. Definitely we'll have class, don't worry. I'm giving an example. Future is uncertain, isn't it? But yet we need to find out the future population. Anything that you can guess tomorrow. So we are going to have class. Day after tomorrow also we are going to have class. We are planning our future, isn't it? So next 20 days we are going to have this class to complete this subject. Something like that. That is called we are planning our future. Using some idea because we have got experience with us. So this subject already I completed many times and many times I completed this subject. So this subject require some 40 hours time, 60 hours time. Quickly want to revise this many hours. So based on that we plan the things. Exactly same way. Based on past we find out, we approximately anticipate so how to finish up this course, something like that. Exactly same way. So anything, future is uncertain, definitely. Finding future population is very, very difficult. That is exactly you cannot work out, but approximately you can find out. Anything approximately, you predict anything approximately, right? That prediction is called forecasting. So we try to forecast future population by using past population data. That past population data already available with the census department. There is one department, they maintain that data. We collect that data, census data. Census data is nothing but census is conducted once in every 10 years. Every nation conducts census once in every 10 years. It is called decennial census. Conducting census every year, that is practically not possible because it takes time, it requires manpower, it requires money, so that is very difficult. So we have got census department, their duty is enumerating the population. Enumeration is nothing but counting the numbers, isn't it? So census is conducted by one department. It's not our duty. One separate department, dedicated department is there. They conduct that census once in every 10 years. Last census they conducted in 2011, right? 2021 is the next census year. Because of corona and all, they could not completed that job. Maybe this year or next year they may take up census job. I don't know exactly. So once in every 10 years, every nation conducts census. So we collect that data, we carefully analyze that data, process that data. By using a proper mathematical method, we try to forecast future population. Therefore, size of the system depends on Q. Size of this water supply system depends on load. What is that load? Hydraulic load, which in turn depends on future population that we choose in the design. So therefore, per capita water demand is also, it also depends on per capita water demand. Per capita water demand is, once you assess the per capita water demand for a given community, it always remains constant, because per capita water demand depends on the local conditions. It doesn't change person to person. Per capita water demand is nothing but what is the average amount of water demanded by an individual living in a community to meet all his day-to-day water needs. It doesn't change much. Okay, so per capita water demand is always remain constant. But what will change from time to time? Population changes from time to time. So Q is straightaway proportional to per capita water demand and population. Because per capita water demand is only one-time assessment, per capita water demand always remain constant. Therefore, the variable here which changes from time to time is population. Therefore, future population we need to make a provision. Our system has to be designed, which is always remain constant. It doesn't change. Only one-time assessment. Per capita water demand is always constant. Only one-time assessment. Once you assess per capita water demand for a given community, that always constant. The only thing that vary from time to time is population. So therefore, population properly we need to. So cost of the system also depends on size. Cost depends on size, size depends on Q. So how much money to be invested in the system, that depends on size. Size in turn depends on Q. Q in turn depends on future population. That's the reason why population is forecasted. Understood now why this topic is there in this course? That's the reason. I hope it is clear to you now. Let us straight away get into the business. So I will talk about population forecasting. You may be thinking that why I am teaching so much theory and all, right? I am giving idea. Population forecasting. Usually the population forecasting is predicting anything well in advance. Approximately working out anything well in advance is nothing but forecasting technique. So we are trying to forecast future population based on present population data available with census department. Okay. Under normal circumstances, population of any community follows logistic curve. One curve is there which is known as logistic curve. That curve is the basis to derive many mathematical methods. So this is a logistic curve. Logistic curve is nothing but a plot between population versus time, which is a population versus time plot. So for every community there is a definite beginning and as well as an absolute end. I am assuming that this end. End means saturation. This is beginning, this is end. So under normal circumstances, population of any community usually follow what? Logistic curve. Start here. So it will go there and finally reach there. If you see this curve is called logistic curve or population growth curve. So the trend of the curve is totally different. From point to point, trend is changing. So whatever is there here, that is different. Whatever is there here is different. So different places, it has got different kinds of growth. Okay. Let me draw properly. Like this. Different places, it has got different kinds of growth. So this is giving so many number of mathematical methods. So this is 0 to A, or otherwise you can write A to B. This is A to B, B to C, C to D, D to E. So there are so many number of, that means slope of the curve is keep on changing. You can see the trend under normal circumstances. This carefully, this curve if you analyze, this curve will yield you, if you subject this curve to mathematical treatment, this will give you, this will yield you so many number of population forecasting methods. So logistic curve is the basis to derive the following population forecasting methods. So I will concentrate more on numericals with a reasonable amount of theory, good amount of theoretical concepts, okay? Population forecasting methods. So we have got 4 methods, popular methods based on this curve only. So this curve, different portions, it has got different kind of growth. Population always increases with the time. How it increases? Whether it is increasing at fast rate or increasing at a constant rate or increasing at a slow rate. So like that, different time periods, it has got different kinds of growth. So based on that, we have got so many number of methods. One is called arithmetic increase method. Okay. For GATE exam point of view, these methods are important. Couple of times they have asked questions from here. Second one is geometric increase method. Sorry. Third one is incremental increase method. Fourth one is exam point of view I am talking, decreasing growth rate method. One more also there, but that is not required for GATE exam. Decreasing growth rate method. One more also there, logistic curve method, numerical method. But we don't require that method because nothing but formula substitution. Such type of questions usually they don't ask in GATE exam. You have to think and answer. With this brain you have to answer. That is where we find difficult, because if you do not prepare properly, if you don't have proper concept, so you'll get confusion. You can't answer the questions in the exam. So formula substitution kind of questions generally they don't ask. Very rare you come across with them. Straight formula substitution kind of question they don't ask. If any such a question is there, indirectly they will give informations. They will confuse you. They will keep some kind of twist in that question. Anyway, that and all different issue. Anyway, arithmetic increase method. Let us see the first method. Only you have to remember formula. That's all. I'll explain you concept behind this. But finally, what you need to remember? Formula. How to work out variables in that formula. That's all. There are some constants. That information is furnished in the question. Some variables you have to work out. So using those variables, remembering formula, substituting in that formula properly, you can arrive at the answers. Population, final, future population. Arithmetic increase method, generally, we use this method for old and settled communities. For old and settled communities, this method is the best. For example, you see, Lucknow is there, Lucknow. Lucknow is the capital of Uttar Pradesh. Even being a capital, if you compare the population growth of Lucknow with population growth of one more city in same Uttar Pradesh state, Noida, it is nowhere. Noida is one of the fastest growing cities in India. Understood? So population is fast exploding in Noida compared to Lucknow. Lucknow is a very old city, right? There are some good universities are there, and is being a capital, it is so much political activity. In spite of that, no way you can compare Lucknow with Noida. Exactly same is the case with Patna. From Gautam Buddha time onwards, we know about Patna and all. This is Nalanda University, this and all. It's an education center, Patna, isn't it? So it's a very old city. When you compare some of the cities, so it is nowhere close to that. Old city, but some kind of growth is there. Definitely population always increases, nowhere it decreases. Always it increases. At what rate increases, that is important. The beauty of GATE exam is, generally sometimes they will give only population data. You don't find the name of the method. If they ask you, solve this problem by arithmetic increase or geometric increase or incremental increase, it is very simple. If you remember formula, if you know how to work out variables in that formula, by simple formula substitution you can work out. But choice is given to you, use a proper method and work out, then you fumble. So for every community it follows only one method. Arithmetic may increase method may be suitable for Lucknow. Same method may not be suitable for Noida. Right? Geometric increase or some geometric increase method is suitable for one community, may not be suitable for some other community. Similarly other methods. So therefore that's what you need to know. When choice is left to you, which method to use to work out population for that community. That's what you need to learn. Isn't it? So arithmetic increase method normally we use for old and settled communities. I am giving few examples. 90% of Indian communities are old and settled. Villages, small towns, they always follow arithmetic growth only. Old and settled communities. We use this method. How do you know that old and settled communities? They don't mention you. Solve problem for old community, find out future population for a old community, settled community, like that. They don't mention. You have to carefully notice the population data. If you compare the population data, right, you find the changes from time to time, right? If that population data shows no much change from time to time, then you can apply, you can assume that just settled community, you can apply arithmetic increase method. That is the trend you need to see. For given dt, dt means the time interval between two successive time periods. Two successive time periods, time interval is called dt. Normally it is decennial census. Census conducted once in 10 years, 1 decade. 10 years is called 1 decade. So dt is nothing but 1 decade usually. Usually decades are years. Normally decades, right? Very rare you come across population data finding year by year, you don't find much most of the time. So only to confuse you, sometimes they'll give yearly data. For given dt, if changes in populations are same, dp1 is same as dp2, dp2 is same as dp3. Like this, past data shows this kind of trend of growth, past census data shows this kind of trend, then comfortably you can apply arithmetic increase method. There is no other method suitable for that community. What I mean to say is, what is dp value, what is this dp, what is dt, I told you already, we discussed. Time interval between two successive time periods is dt. dp is population difference between two successive time periods. Suppose, for example, between ti and ti plus 1. Ti is one time period, ti plus 1 is another time period. The time interval between these two is called dt. So this dt is nothing but ti plus 1 minus ti. So normally it is 1 decade. So population at ti is pi. Census data is available. Population at pi, ti plus 1 is pi plus 1. Okay. This data also are given to you by census department. Then you have to work out dp between these two time periods. So dp between these two time periods is what? Change in population between two successive time periods. dp is nothing but change in population, right, between two successive time periods. That's called dp. So dp1, dp2, dp3, like that, that work out. If almost the same, exact number you don't get same. So in 10 years, some few hundreds, few thousands of difference is there, that is treated as same only. Lakhs, the difference is in terms of few thousand. Suppose population between 1970 and 1980, population difference is 10,000. 1980 to 1990, difference is only 12,000. 1990 to 2000, difference is only 8,000. Something like that is there. That is same as almost close. They are close. Suppose 1980 to 70 to 80, population difference is 20,000. 80 to 90, population difference is 1 lakh. So like that difference is there, you can't apply this method. So that is a drastic difference. Understood? So by looking at the data you can understand. Then you can apply this method. So if the method, only formula you have to remember. So future population have to work out. So future population at a time t, future population at a time tn, otherwise or n, nth time period. Okay, you can take tn or n otherwise. Tn is equal to Tn. We take it as Tn is equal to Pn. How to find out this future population? This you have to find out, isn't it? That was the question. So to work out this future population Pn, what will be given to you? Census data will be given to you. This is census data. This is census population data. Census data is nothing but population data. Past population data will be given to you to find out this Pn. Okay. So this Pn is equal to, I'll straight away write equation, right? Because this is a revision class, so derivations and all not required to you. Nobody will ask you. So it is P naught plus n into x bar. Just you have to remember this equation. So in this equation, Pn is future population at time Tn. What is P naught here? This P naught is nothing but latest population, latest known population. Among all population data, whichever is the latest one, that is taken as P naught. That is population at a time T naught. So the T naught is taken as latest time. Latest known population is taken as P naught. So that is also given to you, census data. In the census only, you will find that P naught. Among all population data, whichever is the latest one, that is taken as P naught. So x bar, what is x bar, what is n? So this n is nothing but number of decades or number of years at which you require population data. Number of decades or number of years. If census data is given in terms of decades, it is number of decades. Census data is given in terms of number of years. Yearly data is given. Census data represented, every year they give data, n is represented in terms of years. Every decade they give data, n is represented in terms of decades. Understood now? So n unit depends on the time units, this t value. So this n value how to work out? It is nothing but Tn minus T naught. If you take Tn minus T naught, you will get number of years, because one decade is equal to 10 years. So how to convert decades, years into decades? So n is equal to Tn minus T naught. So this in terms of years. You want to convert into decades, what you need to do? You have to divide by 10. So 1 year is equal to 1 by 10 decades. From this you can write 1 year is equal to 1 by 10 decades. So this is in terms of years, I am converting in terms of decades. So if you divide by 10 decades, if you just take as it is Tn minus T naught, you will get n value in years. Understood now? So what is x bar? X bar is nothing but, this is nothing but dp bar. X bar, dp bar, both of them are same. What is dp bar? Or okay, otherwise I'll take x bar only. I don't want to confuse you much. X bar is nothing but statistical average, x1 plus x2 dot xm by m. There are m x values are there. If you take average value of these x values, you will get x bar. This is nothing but, in our language, the x bar means here. Of course, it is statistical information only. How we got that statistical information? By using population data. So therefore, this x bar represent what? Average increase in population per decade or per year. Average increase in population per decade or per year. Sometimes x bar is, if n value work out in decades, given in decades, x values are given, time value given in decades, x bar we calculate per decade. Time values are given in years, x value we calculate per year. Average increase in population per normally decades, per decade or per year. So based on x bar how we calculate, based on that n value have to substitute. X bar we calculate per decade, n value should be in decades. X bar value you calculate per year, n value should be in years. Therefore, so if you see this equation, Pn is equal to P naught, population is number, n into x bar. This is you substitute in decades, n value, x bar should be 1 by decade. So decade cancel out, you left with number only again. So if x value calculate in n value calculate in years, so x bar value if you calculate in x bar value must be in average increase in population per year. So here cancel out, you get left with number. So x bar, based on x bar unit, we decide n unit. Either you have to substitute n value in terms of years or in terms of decades. Okay, that is decided later based on how we calculate x bar value. So the only variable here is x bar. So once you calculate x bar, that x bar is assumed to be constant in future also. With the help of that, we work out future population. Understood? So only one thing you have to work, two things you have to work out whenever you are expected to work out future population by arithmetic increase method. One is n value, the other one is x bar value. So P naught is latest population. So substitute in that equation, you will get. Understood now? Am I confusing you? Any confusion is there, you ask me. No problem. This session is open for discussion. Okay, let us solve some few questions, PYQs from the previous year exams. I'll take one question. Okay, I think it is visible to you, right? See this question. The population figures in a growing town are as follows. This ESE question. Year is given, population. This is called census data. The predicted population in 2010 by arithmetic regression method. Arithmetic regression means arithmetic increase method. Okay. Year is given, population is given. With the help of this, we need to work out future population. So all of you take that information, work out. So two things you have to work out here. What are the things you have to work out here? One is x bar you have to find out. Second one is n you have to find out. For this data you have to find out x bar, n. To find out this x bar, x values are required. How to find x at any point of time? To find out x at any point of time, what you need to do? You have to subtract population data between two successive time periods. We have already discussed, isn't it? So x at ith time period is equal to, it is population at, so this is given to you. What is given to you? Population data is given to you. Suppose at a time ti, population is pi, for example. At time ti plus 1, population is pi plus 1. This is census data. This is given to you. This is given in the question. So for this x bar, how to find out? Difference between these two is called dp value. Nothing but xi value. This xi is equal to pi plus 1 minus pi. If you take difference between these two, you will get xi value. Understood now? So like that, x1, x2, x3 we will work out. Then once you got x values, then x bar you can take out. Then you can work out n value based on the data given in the question. Come on, try all of you. So two things are to work out. One is x bar, other one is n. First to take the data. 40,000, 46,000, 53,000. In a chronological order it has given. Arrange the data in chronological order only. That means past to latest. So what is given to you? In this example 1, a ESE question, that is, I am taking the help of table for your comfort. Okay, TI this population PI. 1970 TI is given in terms of 1980, 1990 time periods and 2000. Isn't it? 70, 80, 90, 2000, 40,000, 46,000, 53,000, 58,000. So this is given to you. 40, 46, right? 40,000. This is 46,000. Then 53,000, 58,000. Okay, this is given to you. Then using this you have to find out what xi simply. What is xi? Pi plus 1 minus pi. So between these two time period, this is pi plus 1 pi. Between these two time period, this is pi plus 1 pi. Between these two time period, this is pi plus 1 pi. So between these two time periods, what is the difference in population? 6,000. Between these two time periods, this minus this, 7,000. Between these two time periods, difference is how much? 5,000. So this is x1, this is x2, this is x3. Can't you work out x bar? What is x bar? X bar is equal to x1 plus x2 plus x3. Three values are there. If you take average of these three values, you will get x bar. Come on, work out. 6,000 plus 7,000 plus 5,000 by 3. You don't require calculator. Check in ESE exam without calculator you have to work out. You can manage 6 plus 7 plus 5. 18. 18 by 3 it is 6,000. 13 plus 5, 18. 18 by 3, 6,000. So x bar is 6,000. So you got x bar value 6,000. That's all. You have been asked to find out in which year? 2010 by arithmetic regression. 2010. So what is your P naught? Among all population data, whichever is latest, that is taken as P naught. If this is P naught, what is become? This is T naught. So when you require population? 2010. What is population in 2010? That is called PN. Understood now? So how many decades are separated between 2010 and 2000? 1 decade. Right? How to find out that? N value. So second thing, what you have to work out? N value. So because population data is given per decade, so I'll work out. Tn is 2010, T naught is 2000 by 10, so it is 1 decade. So we've been asked to find out population after 1 decade. What is generalized formula? Pn is equal to P naught plus n into x bar. Population after 1 decade is equal to population in 2010. So which is equal to P naught. Among all this population data, which is latest? It is not 40,000. Latest I am talking. 70th population, 80th population, 90th population, 2000. Which is latest one? 58,000. That is taken as P naught plus 1 decade. X bar we got already 6,000. So 58,000 plus 6,000, how much it is? 64,000. So this is how we need to work out. Clear now? ESE question without calculator you can comfortably manage. 64,000 option is there or not? C option. C option is the right option. So similar type of question if they ask in GATE exam, arithmetic increase, straight formula substitution kind of thing they don't ask. Try this question. The present population of a community is 28,000 with an average water consumption of 4,200 meter cube per day. The existing water treatment plant has to design capacity of 6,000 meter cube per day. It is expected that population will increase to 44,000 during next 20 years. The number of years from now when the plant reached its design capacity, assuming an arithmetic rate of population growth. That means indirectly it's GATE question. Indirectly is asking use arithmetic increase method to work out this unknown. So what he has given is example 2. GATE question this is. So I'll read the question once again. The present population of a community. Present means latest. Present population is taken as latest population, that is taken as P naught. So at that time how much water they are supplying? 4,200 cubic meter per day, that is Q. Q at that time is 4,200 meter cube per day. So at the time present population T naught, that is P naught. The present population of a community is 28,000 with an average water consumption of 4,200 meter cube per day, that is Q. I'll take it as 0 time, right? At that time population is 28,000 and how much water they are supplying? This 28,000, 4,200 meter cube per day they are supplying. Q they are supplying is using a system 4,200 meter cube per day. Understood? So what else is given? The treatment plant is designed for a capacity of 6,000 meter cube per day. But this treatment plant designed for what discharge rate? Design flow rate is what? Future population is designed. Future discharge design is 6,000 cubic meter per day. It is designed for 6,000 cubic meter per day. That was mentioned there. It is expected that population will increase to 44,000 in the next 20 years. He is saying that in the next 20 years, that is T20, I am taking next 20 years, The population of community is increasing to 44,000, increasing at arithmetic rate. He mentioned that indirectly arithmetic increase method you have to use. Arithmetic rate. Okay. Then what is the question there? Then the number of years from now when the plant reached the design capacity, because plant is designed for capacity how much? 6,000 cubic meter per day. Present they are dealing only 4,200. How many years it will take to deal 6,000 cubic meter per day of water by the water supply system? Is asking that. That means indirectly asking Tn value. This Tn is asking nothing but n, because I took n is equal to what? Tn minus T naught. N is equal to Tn minus T naught. So I took T naught as 0. Therefore, n is nothing but Tn minus 0, nothing but Tn only. So when it reaches to its full capacity, when population increases arithmetic rate, what is future population? P naught into n into x bar. Okay? P naught into n into x bar. P naught is known to you already, 28,000. So what are the unknowns here? N is unknown, x bar is unknown. But what have been asked to find out? N value. When time reaches to n, it starts treating water to its full capacity, 6,000 cubic meter per day. So this is also known. So to find out x bar indirectly, this information is given. In the next 20 years, the community, population of that community increases to 44,000, increasing at arithmetic rate. That means in the 20 years, if you work out, so what is population forecasting formula for 20 years? It is 20 into x bar. Here x bar 20 I took in years, therefore x bar is calculated per year, you have to calculate. Okay? So 20 into x bar, which is nothing but 44,000. He has given that value. So it is increased at arithmetic rate. Can't you work out x bar? P naught is always constant, 28,000. Here also 28,000. It is 28,000 plus 20 into x bar is equal to 44,000. From this, can't you calculate x bar? You can calculate. Okay? You can calculate x bar value. So x bar is equal to x bar is equal to how much it is? Average population, nothing but. So this x bar is equal to, it is 44,000 minus 28,000 by 20. So it is increasing at 800 per year. So x bar calculated per year. Therefore, n value we get in years. If x bar value calculated per decade, n value will get in decades. Understood? Okay? But he is asking n value, not x bar. So how to find out n value? So x bar we got. So Pn also unknown, unfortunately. So to work out Pn indirectly, what is Q? Q is equal to what? Population into per capita water demand. Just now we discussed per capita water demand always remain constant. Per capita water demand never changes from time to time. Always it remain constant. Therefore, per capita water demand is equal to, irrespective of time, it remain constant for a given community. With the time, for a given community, only population increases, not per water demand. Q by population. Isn't it? Simply I can write it as Q by P. Q by P is equal to per capita water demand. That always remain constant. It doesn't change from time to time. Therefore, from this I can write at the time T naught. So, discharge is Q naught. Population it is serving is P naught. At the time Qn, discharge is Qn. Population it is supposed to serve is Pn. Right? So, Q naught value already we got. What is Q naught value? 4,200 meter cube per day. Population it serving is how much? 28,000. Qn also known to you. Plant is designed for Qn. 6,000 meter cube per day. What is Pn? Pn already got. 28,000 plus n into x bar. X bar already we got here. So 28,000 plus n into x bar is 800 per year. So if you solve this equation, you will get how many years it will take to reach the population to its design capacity. Come on, work out all of you. Simplify this. I am also doing along with you. Do it. So if you work out this, how many years will get? 15 years. So if you don't have this idea, per capita water demand constant, then this problem is a puzzle to you, because two unknowns, one equation you can't solve. It is a trivial. So you're supposed to know the concept. That's why concepts always very, very important. concept followed by numericals if you solve, then you are very comfortable. Any exam you write, let him ask any type of question comfortably, you can answer. Clear now? This question is been asked in GATE 2004. So next you may expect that in this question n is asked, n you have been asked as unknown. You may ask Pn also unknown. Sometimes you may give Pn also, X bar also. Sometimes you may ask you per capita water demand. Anything could be unknown. Right? What is the per capita water demand for this community? So information is given, you can work out if you have this idea. So it could be anything. Either n could be unknown, or it could be Pn is unknown, or it could be n, or it could be per capita water demand also. So anything, anyone could be unknown, so comfortably you can work out if you know the concept. Okay, this is about arithmetic increase method. I hope it is clear to you. Second method, geometric increase method. People also call it as logarithmic growth method or exponential growth method. Second method is geometric increase method. Normally, the geometric increase method is best suitable for most happening communities. That means fast growing communities. If you see in India, you can count very few communities are fast developing communities, fast growing communities in terms of population, in terms of everything. Okay, you can count on fingers. Just now I discussed Noida, Greater Noida. Noida is in Uttar Pradesh, one of the fastest growing cities in India. Noida. Why it is fast growing community? Because it is very close to New Delhi. Delhi is no place in Delhi to further growth. If you just if you come to the outskirts of Delhi, it is Noida starts, isn't it? So that's a blessing because it is close proximity to Delhi. So almost it is in Delhi only. Noida is nothing but a Delhi, isn't it? Delhi suburb is Noida. So one of the fastest growing communities because everything is there in Delhi. Nothing need to be provided. International airport is there, right? Good connectivity is there, metro network is there, everything is there. So therefore, no place is available in Delhi to start any new thing. Therefore, they have to look at Noida only, isn't it? Similarly, Gurgaon. Gurgaon also close proximity to Delhi. When compared to Chhattisgarh, what is the capital of Haryana? Gurgaon is in Haryana, isn't it? Capital of Haryana is Chandigarh. Compared to Chandigarh, the rate at which Gurgaon is increasing is tremendous. One of the fastest growing community because that is also very close to Delhi. So because of close proximity to Delhi, both Noida and Gurgaon, one of the fastest growing cities in India. Similarly, one of the fastest growing cities in the world is Bangalore. Bangalore is one of the fastest growing cities in the world. The rate at which it is growing is unimaginable because so much land is available in all directions. It is fast growing because of software companies, because of aviation sector, because of electronic industry, because of education industries. All startups are in Bangalore only. So one of the fastest growing communities in the world is Bangalore. Similarly, Hyderabad. Similarly, even though Hyderabad is a old city, but still you cannot apply that arithmetic increase method. You have to apply geometric increase method because it is fast growing community. The reason being pharma industry, the reason being software industry. So pharma industry, software industry took Hyderabad to next level. It is not a local community, it is a global community. Bangalore, Hyderabad, Pune. Pune also one of the fastest growing communities in Maharashtra state. Because Mumbai is overcrowded, no place available in Mumbai. So you want to start anything, Pune is the best place. Cost of living also less compared to Mumbai. Land is available, water is available, better infrastructure is there, better connectivity is there. So Pune is one of the fastest growing cities in India. Similarly, the Surat in Gujarat, diamond cutting industry, textile industry took Surat to next level. So there are some reason is there for the growth. So due to obvious reasons, communities fast grow. So for such communities, the best method to work out future population is geometric increase method. This method is suitable for best for young and rapidly growing communities or fast growing communities. Young communities, youngsters, their growth is very fast, isn't it? Old person like me, right? Old person like me, I lost my job. I lose my jobs very frequently because people say that, sir, you are very old, you don't have energy, you can't teach properly. Youngsters are shouting in the class, they are cracking jokes, they are teaching in Hindi. I can't speak Hindi properly. So therefore I am finding difficult for myself to survive in education industry because I have become old. So youngsters like you, so if you are coming to this teaching profession, they are doing very well. The reason being, they have got energy levels, right? So they have got a very bright future. Their salaries are tremendously increases. For my salary, instead of giving increments, I am getting decrements. Compared to last 5 years, whatever salary I got, this year there is not much salary with me, isn't it? Because old person, I become old, people are not giving chances to old people. So anyway, that and all different issue. Normally, young cities, growth is very, very fast. See now, youngsters only go for any job, youngsters only they prefer. The reason being, the energy levels and as well as the enthusiasm to learn, that will be more with youngsters when compared to old people. Definitely, growth will be more for them compared to old people. So young and exactly same is the case with young cities also. Young city, tremendously it grows because of obvious reasons. Land is available, right? Because of better infrastructure, better connectivity. Suppose, for example, you see Amaravati is a state capital of Andhra Pradesh at present. I don't know, still this government not yet recognized, but still at present Amaravati is there. Amaravati is an open land, so therefore everything, whatever you can have, whatever you want to construct, you can construct. So because it's been elected, so it is a small village. Right now it is a village, a population of 10,000 living there. Suppose it remains as a capital in the next 10 years, not less than 10 lakh people live in Amaravati because it's a capital. People go there and work there. So many educational institutes come up there. Software companies also start there. Connectivity, road connectivity, this connectivity, development happens automatically. So they grow. So young and rapidly growing communities, we apply which method? Geometric increase method. This justification is required. How you know that? In the exam they don't give you, so you need to see the trend, population, census trend. So same way for given dt, if you observe the dp values for past census data, for given dt, if dp values are dp1 is less than dp2, dp2 is less than dp3, then you can comfortably apply this method. Okay, substantial differences are there between dp values, then you can apply this method. There is no much substantial differences in dp values. Which method you have to apply? Arithmetic increase method. I wrote here. I wrote here. dp values are almost same. You can apply arithmetic increase method. dp value changes from time to time. Substantial increases. Last year you got a salary of 3,000. 3,000 increment is there last year. This year you may get some 15,000 increment. That's a substantial increment. Last year I got increment 3,000. This year I got increment 4,000. That is not substantial increment, isn't it? So such type of trend is there. You can apply geometric increase method. Again here you have to remember only formulae. So in geometric increase method, Pn is equal to, it is P naught into 1 plus R bar by 100 whole power n. P naught and n carry same meaning. Extra thing is R bar. There X bar you have to work out. Here R bar you have to work out. Or otherwise one more formula which is also equal to e power r into or r bar into or r otherwise Tn minus T naught. This way also you can work out. So when r value or r bar value given to you, you don't require census data. Substitute in the formula and get the answer. If census data is given to you, r bar you have to work out. This r bar is equal to geometric average of, this is percentage increases, percentage increase in population. Geometric average of percentage increases in population. Percentage increase in population. Geometric average is different, simple average is different. R bar is equal to, it is not R1 plus R2, it is R1 into R2 into Rm whole to the power 1 by m. M R values you have to when we arrive at m r values with the help of population data, then r bar calculated like this. Okay. If r bar value already given, it is well and good. No need of working out, no need of census data. Straight away you can substitute in the formula. P naught is same thing. How to work out r values? So this r at any point of time is equal to percentage increase in population. Ri is equal to pi plus 1 minus pi. This increase in population by original population into 100. This is nothing but percentage increase in population between two successive time periods. Understood? At a time ti plus 1, population data is given to you pi and pi plus 1. Okay? At time ti and ti plus 1, population data is pi plus 1. So during between these two time periods, what is r value? Ri. How to find out that Ri value? So change in population by original population. Increase in population by original population into 100. So this is how you can work out R values. Using R values, R bar you can find out. Then after that formula substitution only, nothing is there. Understood? Am I confusing you? So last question, last method, only xi values have to find out. In this method, right, that xi value have to divide by pi. Ri is nothing but pi plus 1 minus pi is nothing but xi. Xi by pi into 100. That's all. This way also you can work out. Okay? This much idea is there. Comfortably you can work out future population by geometric increase method. Clear? Am I confusing you? Am I confusing you? Any confusion is there, you can ask me. Any confusion is there, you can ask me. हिंदी में बोलिए सर, पूछ रहे हैं आप लोग. हिंदी थोड़ा थोड़ा जानता हूं भैया हिंदी, मगर कोशिश करेंगे डेफिनेटली, बट यू विल लाफ बाय सीइंग माय हिंदी. आई बिकम ए लाफिंग स्टॉक बिफोर यू. थोड़ा थोड़ा बोलने के लिए मैं कोशिश करूंगा डेफिनेटली, बट what is important is content is important. That idea has to go into your mind, that's all. Whether I speak in Hindi or English or Telugu, whatever it may be, content is more important, isn't it? I'll try to. समझ गया भैया? समझ लिया? Method is clear to you? Method is clear to you? और comment करो वहाँ. Method is clear to you? और comment करो वहाँ. My Hindi is horrible. Okay? कोशिश करूंगा मैं हिंदी में बोलने के लिए, बताने के लिए, बोलने के लिए. I'll try. Okay then. Let us solve one question, simple question. Before we close today's session, let us take up one question. The population of India in the year 2000 was 1 billion and it is increased in an exponential manner at a rate of 1.6% per year. If the growth rate is maintained, what will be the population in the year 2020? In the year 2000, it is given as 1 billion. What is population in the year 2020? It is growing at exponential rate. Exponential rate means what? Which is also known as nothing but geometric growth only. So in statistics they call geometric growth. So mathematically it is called exponential growth or logarithmic growth. Logarithmic term is there while deriving that equation. Because E is there, no E, exponential growth. E term is there. If you remove this E, logarithmic term also will come there. Okay, anyway. So what is given in that question is, in that example, this question is given in that NPTEL lecture from IIT. IIT website, NPTEL study material is there. In that it is there. So NPTEL questions also they will ask in GATE exam. So population in 2000 is given. Population in 2000 is taken as P0. That is 1 billion. Let us write billion only, don't put zeros and all if you get confusion. What is population in the year 2020 is asking, that is taken as Pn. What is population in 2020? This we have to work out. And he mentioned that population is growing at exponential rate. Exponential rate means geometric rate. So you have to apply geometric growth rate method. At a rate, what is that? R bar is given 1.6% per year. So R bar is given in terms of years. N value you have to work out in which unit system? Here T naught is equal to 2000. You have to work out population in the year 2020. Tn is 2020. N value you have to work out in years only. So it is Tn minus T naught. 2020 minus 2000. So after 20 years you have to work out. Okay. So which formula you can use? This any one formula you can use. Both of them are good. So directly this is given. Substitute in this equation. Tn value T naught is also given. Of course, N also you can write here instead of that. Either you can use this equation or that equation. Both will give same answer. So let us try. Pn is equal to P naught into 1 plus R bar by 100 whole power n. So P naught is 1 billion. 1 plus R bar is 1.6% per year. N is 20 years. Come on, how much you are getting? 1.37 billion. That's how we can work out this problem. Understood? Or otherwise, other formula also you can use. That also will give same equation. Normally this is statistical information is given, we use this formula. Normally R bar is given, straight away you can use that formula also. See now, let me use that formula also. Pn is equal to P naught into e power R into Tn minus T naught. So R is to be substituted 1.6% per year. 1.6% means 1.6 by 100. So 0.016 per year. 1.6% per year means 1.6 by 100 per year. Isn't it? So P naught is 1 billion e power 1.6 by 100, 0.016 only, no? 0.016. Tn minus T naught we got already 20. Come on, try. Find out answer. You will get same answer. I also am trying along with you. So it is e power 0.016 into 20. So 1.377. So both methods, both formula will give same answer. Okay. So normally population statistics are given, we use this formula. Statistics are not given, straight away R value given. You can use straight away this formula, we don't require statistics. Understood? So two methods we completed. So two more methods tomorrow we'll take up. Tomorrow I'll be starting class very early. It's 5:30. 5:30 to 7 I will take tomorrow due to some preoccupied business. So I preponed your class to 5:30 to 7. Do join tomorrow. Do join all the classes. Do attend all the classes so that comfortably you can answer all of the questions from this course. That much I can assure you. If you attend this session, comfortably 100% you can answer questions in GATE exam. Okay. Okay. Good night all of you. Thank you very much. But stay back and attend classes. Okay.